Okay, Unit 4 for third year triple E digital signal processing. Um, with some triple E analysis syllabus. So first topic is FIR and IR filter design. So basically we have to know before design the FIR and IR filter. So this is adder. So adder x1 of n, x2 of n. There are two signals. So it's a discrete signal. So if you're going to add, and then you will be get the output y of n is equal to x1 of n and x2 of n. And x1 of n, x2 of n, that's a summation. Even if you put the plus or summation, that is also same. Y of n is equal to x1 of n plus x2 of n. Then multiplication x of n and a y of n is equal to a xn. So there is a multiplication and x1 of n and x2 of n. Y of n is equal to x1 of n dot x2 of n. So here we are multiplied. Here the factor is multiplied with the input, and here two input signal discrete signals are multiplied. Delay element. So x of n is it inverse. So delay element means so delay element z minus 1. So y of n is equal to x of n minus 1. So here if delay element, if that is representing z inverse, so the delay values, the time value is n minus 1. So here x of n is at minus k. So y of n is equal to x of n minus k. So whatever the value is there, you have to put it uh, minus k. And time advance element. So x of n, that is equal to y of n is equal to x of n plus 1. So this is advanced element. So x of n is at k. So x of n plus k. And this is a relation of IR filter. So we know that transfer function of IR filter. So this is a relation of IR filter formula. H of z is equal to h1 of z, h2 of z. Okay, then IR filter can be realized in many forms. So the classified into direct form 1, direct form 2, cascade form, and parallel form. And direct form 1 realization. So this is a formula. This is the structure for direct form 1. So center place it is positive is there, and left and right is it is the inverse. X of n is input and y of n is output. And b0, b1, b2 so variables they given a1, a2, a up to an minus 1. So here the example they shown obtain the direct form 1 relation in difference equation to the 0.7 y n minus 1. So using this difference equation, so solution y of n is equal to 0.7. So they given the value, then you know that omega n and um, because the value you will be getting here omega n. So this is the value. So x of zero point 0.7 n minus 1 zero point 4. Okay, and this is the value. This after this equation is they can say as a omega n value, and this is y of n value. So there are two equation is there. So this equation totally they consider as a y of n. So plus y of n they written here. So this is realization from diagram. So I of n. So see, so zero point 0.7. So this is output side, and this one is that y of n side, that input side. So output side zero point 0.7 y n minus 1, point minus 0.45 y n minus 2, and plus 0.25 n minus 3. So that is in output side. So n minus 1, so one delay is there. So after one delay, you have to put the value zero point 0.7 y n minus 1, 1 n minus 2, 0.45, then 0.25 for y n minus 3. Then plus omega n, that means the input value x of n value. So this is x of n value, then zero point 0.2 x of n minus 1, zero point 0.4 x of n minus 2. So this is omega n. Then the arrow is very important. So x of n under that zero point 0.2 n minus 1 and n minus 2 is zero point 0.4. See the given value also x of n. So x of n, the total part is x of n minus 1, it's zero point 0.2, n minus 2 is a zero point 0.4. So this is the relation for one example. The another example similarly same. So see that the first one is y of n and x of n value. The second one, the x of n, the total values we consider say omega n. So there are two equations. So this is the last how the previous example we saw that similarly. So this is an example. Just write it omega n. So this part you have to put it in output side. The x of n value put it in input side. So n minus 1 is at the inverse. Then is at my 2 delay, and here 1 delay and 2 delay. So there is a diagram. So this is a final diagram. So output side. So equation. So 2 n minus 2 3. So there is 2 and 3 after 1 delay and then 2 delay. Then y of n. The format is same. Y of n. Then x of n is input value n minus 1 and n minus 2 2 4. 2 4. Okay. So this is the way they will be calculate. So this is another part, numerator and denominator. So they have the equation. So numerator part and denominator part. So they have to split the value. Uh, Actually, multiply the transfer function h of z equal to 2z minus 3 to obtain the standard form of transfer function. So they have to multiply with the equation, and you got the value. Then h1 of z the value, and h2 of z this is the value. So numerator value is h1 of z, and the denominator value is h2 of z. So the numerator value, that is put it in input side. So 1 delay and 2 delay and 3 delay, zero point 0.2, and denominator value, that is put it in output side. So already the 1 is there, so 1 you can write it here, or you won't write it. It's not a problem, it is not noted. So zero point 0.4 and points minus zero point 0.6, and then zero point 0.1. So this is direct form 1 realization example. Thank you.